Welcome to MRL. In this learning session, we'll be learning about circles. Now, what is a circle? A circle is a set of points in a plane that are at a fixed distance from a fixed point. The fixed point is known as the center of a circle. A circle is also defined as a coplanar closed geometrical figure formed by tracing a point at a fixed distance from a fixed point. O is the fixed point, R is the fixed distance, and the point A traces the circle. So that is what is the definition of a circle. Now, circumference. The boundary or perimeter of a circle is called circumference. The boundary or perimeter. So this is the boundary or the perimeter of a circle, and that is called as the circumference of a circle, and it is denoted by C. Radius is a line segment joining the center to any point on the circle. Radius is a line segment joining the center to any point on the circle. Here O is the center and A is the point on the circle, then OA is the radius. Therefore, radius is a line segment joining the center to any point on the circle. Radius is also a measure of the length of the line segment OA, and radius is denoted by R. Remember that. Now, what is a chord? A line segment joining any 2 points of a circle is called a chord. So we have a circle C1 here. A and B are any 2 points on the circle. If AB is joined by a line segment, then AB is a chord. AB is a chord. Infinite chords can be drawn in a circle. Please remember, infinite chords can be drawn in a circle. Diameter. A line segment passing through the center of a circle and joining any 2 points on the circle is called a diameter. So if you have a circle C1 here, there are 2 points A and B, and the line segment AB is joined and which passes through the center, then AOB is the diameter, and it is denoted by D. Now, diameter is also a measure of the length of the line segment AOB. A diameter of a circle is also defined as a chord or the biggest chord or a chord which passes through the center of the circle. So please remember that. In a circle, the longest chord is the diameter, or a chord that passes through the center of the circle is a diameter. Infinite diameters can be drawn in a circle, and all the diameters of a circle are equal. Remember that. Now, relation between the diameter and radius of a circle. Now, AB is the diameter of the circle C1 here. OA and OB are the radii. OA is equal to R, OB is equal to R, and AB is equal to D. So therefore, D is equal to 2R, or R is equal to D upon 2. So therefore, remember, the diameter of a circle is twice radius, or radius of a circle is 1/2 of the diameter of the circle. Arc of a circle. A continuous portion of a circle is called as arc of a circle. So if you consider a circle here, now it has a circumference. If I take a continuous portion of the circumference of the circle, that is AB, then that is called as arc AB, denoted by this symbolically. So this is arc AB. Now, any 2 points on a circle divides a circle into 2 arcs. One arc is arc AB, the other arc is arc BA. Now, if you see that arc AB is smaller and arc BA is bigger, the smaller of the arcs is called as the minor arc, and the bigger arc BA is called as the major arc. Therefore, a circle is divided into 2 arcs here. Please remember that. And these 2 arcs are called as conjugate arcs. So conjugate arcs are the 2 arcs formed, that is AB and BA, and when we add the 2 conjugate arcs, we get a circle. So 2 arcs that form a circle when joined are called as conjugate arcs. Please remember that. Now, coming to the next point, that is semicircle. 1/2 of the circumference of a circle is called as a semicircle. 2 distinct points on the circle divide the circle into 2 halves. Each half is a semicircle. For example, now here I have a circle. The points A and B are 2 distinct points on the circle, and these points AB divide the circumference of the circle into 2 equal arcs. That means arc APB and arc AQB formed are equal arcs of the circle, and these 2 equal arcs are called as semicircle. Therefore, we call the semicircle as one half of the semicircle, or 1/2 of the circle. Circumference is the longest arc of a circle. Now, degree measure of an arc. The measure of angle subtended by an arc at the center is called degree measure of an arc. Again, I'll repeat, the measure of an angle subtended by an arc at the center is called degree measure of an arc. Degree measure of a minor arc. If you look here, arc AB is a minor arc. It subtends an angle at the center of the circle, and that is degree measure of the minor arc, and it is less than 180 degrees. So also the major arc AB subtends an angle at the center, and it is more than 180, and remember that it is a reflex angle, it is more than 180 degrees. And so also the degree measure of semicircle. Please understand here, points A and B divide the circle into two equal arcs, which are called as semicircles, and the angle subtended by a semicircle at the center is 180 degrees, and the angle subtended by the complete circle at the center is 360 degrees. Remember that. Now segment. A segment is a region of a circle bounded by a chord and the arc, whose endpoints are also the endpoints of the chord. A chord divides the region of a circle into two segments. Now let me explain this to you. We have a circle here, and AB is a chord. The chord AB divides the circumference into two arcs. We have got arc AB here and arc BA here. Now the segment is the region. This is the region here, this region. So it divides into two segments here, these two segments here. One segment is ABA, other segment is BAB, and that is what is called as a segment. Therefore we define a segment is the region of a circle bounded by a chord and a minor arc or a major arc, and divides the circle into two segments. One may be a minor segment, the one which is smaller is called as the minor segment, and the one is bigger is called as the major segment. Therefore we call them as minor and major segment. A chord divides the region of a circle into two segments. The region of a circle bounded by the chord and minor arc is called as minor segment. A minor segment is a segment which does not include the center of the circle in it. The region of the circle bounded by the chord and major arc is called as major segment. A major segment is a segment which includes the center of the circle in it. Now if you observe these two diagrams here, AB is a chord and arc AB is a minor arc, and ABA is a minor segment. Whereas if you look at this figure, AB is a chord and BA is the arc, BA is a major arc, and therefore this is a major segment. Remember that. So this is how. And also one more important point, in a minor segment the center of the circle is not included, whereas in a major segment the center of the circle also gets included in the major segment. Remember that. Now semicircular segment. The region of a circle bounded by a diameter and a semicircle is called semicircular segment. So if you consider here in this diagram, AB is the diameter and AQB is a semicircle, and also AAB the diameter and APB is a semicircle. So therefore a circle, the region of a circle is divided into two segments which are equal, and each segment is called as a semicircular segment. Therefore we have the ABQA is one segment which is called as semicircular segment. Therefore the region of a circle is divided into two segments by a diameter. Remember that. Now division of a plane by a circle. When you draw a circle in a plane, it divides the plane into three parts, that is the interior of a circle, the boundary of a circle, and the exterior of a circle. Remember that. And the points which lie in the interior are called as interior points, and those which lie outside are called as exterior points, and those which lie on the boundary or the circumference is what is called as the points on the boundary of the circle. Remember that. Now here the point A is the interior. Point A is interior to the circle. The center of the circle is interior to the circle. Then we have got the other points are whichever the points you consider. That means if you look at the interior points, the distance from the center is less than radius of the circle. If the distance is equal to the radius of the circle, then the points lie on the circle, and if it is more, then the point lies outside the circle, then that is an exterior point. Remember that. Now point on the boundary of a circle, as I have told you, the point on the boundary of a circle is lying on the circumference, and its distance from the center is equal to the radius of the circle. So P is the point on the boundary of the circle, and OP is always equal to the radius of the circle. Now circular region. Circular region means the portion of the plane within the boundary of a circle is called as the circular region. So the part of a plane which lies within the boundary of a circle is called as circular region. Now area of a circle is the measure of the circular region including its boundary is known as the area of a circle. Therefore area of a circle is circular region plus the boundary of the circle. Now what is the relation between the circumference and diameter of a circle? If we measure the circumference C of a circle and also measure the diameter D of a circle and take a ratio of it. If you take the ratio of that means take the ratio of C and D, that is C upon D is a constant equal to 22 upon 7, and 22 upon 7 is denoted by the symbol pi, and therefore C upon D is equal to pi, or C is equal to pi D. But we know that D is equal to 2r, and therefore C is equal to 2 pi r. So C is equal to pi D and C is equal to 2 pi r are very important relations to find the circumference of a circle if diameter is given or the radius is given. Remember that. Now the next important discussion is sector of a circle. Now what is the sector of a circle? The region of a circle bounded by two radii and their corresponding arc is called sector of a circle. Let us understand here. Now if we have a circle here C1 and OA and OB are the two radii and arc, we have an arc AB. Now the region which is bounded by the two radii and the arc AB is called as a sector. Now this sector being sector, and it is, remember that the points of radii on the circle are the end points of the arc also. Now two radii drawn in circle divide a circle into two sectors. Here this is one sector, this is another sector, and each of those sectors are called as minor and major sector. The minor sector is the region of a circle bounded by two radii and a minor arc, and whereas the major sector is the region of a circle bounded by two radii and the major arc. So we have OA and OB are the radii, arc AB is the minor arc, therefore ABOA is the minor sector, and here OA and OB are the radii and arc BA is a major arc and BAOB is the major sector. Remember that. Therefore a circle is divided into two sectors by two radii. One is the minor sector, the other one is the major sector. Remember that. Angle in a segment or inscribed angle. An angle whose vertex lies on the circle and its arms cut the circle at two distinct points is called as inscribed angle. Now if you look at the figure, PAQ is an angle. The vertex of the angle lies on the circumference and the arms of the angle, that is AP and AQ, cut the circle at two distinct points P and Q. Therefore angle PAQ is called as inscribed angle. An arc subtending an angle at the circumference is an inscribed angle. Therefore we have an arc here, that is arc PQ, subtends an angle at the circumference, and that is called as inscribed angle. So the angle PAQ is inscribed angle, or angle PAQ is the angle subtended at the circumference of the circle. Remember that. And subtended, now here PAQ is a minor arc, therefore it is angle subtended by a minor arc. Remember that. Now angle subtended by an arc. If you consider an arc, it subtends an angle at the center called as the central angle, that is angle AOB, the central angle, and it subtends an angle at the circumference or inscribed angle, that is called as angle APB. So angle APB is the inscribed angle and AOB is the central angle subtended by one arc, that is arc AB. Now relation between central angle and inscribed angle subtended by an arc. So if you consider an arc here, arc APB, it subtends an angle at the center and outside the circumference. Now if angle at the circumference APB is x, then the angle at the center AOB is double that, it is 2x. Therefore the angle subtended by an arc at the center is double the angle subtended by the same arc at the circumference. Please remember that. Now the measure of the central angles and inscribed angles subtended by minor arc, major arc and a semicircle. So let us understand this very clearly. Now let us take a minor arc first, that is arc AB, the minor arc here. Now arc AB subtends an angle at the center, that is called as the center angle, which is less than 180 degrees, but natural that angle APB is less than half of 180, that is half of 180, and it is less than 180 means it has to be less than 90 degrees, which is an acute angle. So the angle subtended by a minor arc at the circumference is an acute angle, and the angle at the center is less than 180 degrees. Now if you take a major arc, here we have arc AB, which is a major arc. The angle subtended by the major arc AB at the center is greater than 180. the arc, the same major arc subtends an angle at the circumference which is half of the angle subtended at the center, therefore it is greater than 90 or an obtuse angle. Now the angle subtended by a semicircle is the angle here at the center is 180 degrees, the central angle of a semicircle is 180 degrees, and therefore the angle at the circumference is half of that, and that is 90 degrees. So please remember that. Now angles in the segment. Angles in the segment are equal. Now if you take the segment here, major segment here, the angles APB and AQB are the angles in the major segment, and both the angles are equal. So angles in the same segment are equal. Angles in a major segment are but definitely acute angle. Angles in a minor segment are obtuse angle. Angles in a semicircular segment are right angle. So please remember that, and the reason is very simple, because the angle subtended at the center by the arc is less than 180, therefore the angle subtended at the circumference has to be less than 90, therefore they are acute, and same reason is explainable here, or explains for these two circles also. Now secant. A line which intersects a circle in two distinct points is called as a secant. This is a line PQ. It cuts the circle in two distinct points A and B, and that is called as a secant. So therefore a secant is a line which cuts the circle in two distinct points. So PQ is a secant. Now whereas here if you see, the AB is also a line, but AB cuts the circle in only one point, and this point is called as point of contact, and APB is called as the tangent. So therefore we define a tangent is a line which intersects the circle in only one point. The point of intersection is known as the point of contact. So these were some basics and properties of the circles and related terms of circles. So please learn all these basics. In our next learning session, we will be learning the properties of chords, and also solve or prove the theorems related to chords, and then further we'll go for other aspects of learning of the circles. Okay, note down in our book. Please practice, learn. Thank you.